We present Correlational Image Modeling, a novel and surprisingly effective approach to self-supervised visual pre-training. Recent advances in self-supervised video pre-training have shown great capability in harvesting meaningful representations from millions of easily accessible unlabeled images. Such a learning process typically consists of two main steps. First, we train a deep model on unlabeled images with non-trivial and meaningful self-supervisory pretext tasks. Then, the model is fine-tuned on downstream labeled images in self-supervised learning. In this way, the pre-trained representations would be transferred to downstream tasks. Among existing pre-training paradigms, multi-view self-supervised learning and mask image modeling are two leading methods in the self-supervised learning research. MVSSL follows an augment and compare paradigm, randomly transforming an input image in two augmented views and then comparing two views in the same representation space. On the contrary, following the successful mask image modeling, MIM conducts a mask and predict task within a single view, removing a proportion of random image patches and then learning to predict the missing information. Beyond these two typical preset tasks in this paper, we endeavor to investigate another simple yet effective paradigm for self-supervised video representation learning. We take inspiration from video tracking and computer vision that defines the task of estimating the motion or trajectory of an exemplar object in a sequence of thin images to cope with challenge factors such as scale variations, deformations, and occlusions. One typical tracking pipeline is formed as maximizing the correlation between the specific exemplars and holistic context. More formally, in deep visual tracking, given an exemplar image along with a typically large context, the correlation is defined as measuring the dense similarity of two high-level representations in a 2D fashion. Here, theta is backbone model to extract corresponding representations. The star symbol denotes a correlation operator. In standard semi-space trackers, the correlation operator is normally instantiated as a 2D convolution, in which the exemplar features take the role of convolution kernels, sliding over the spatial region of context features. While for transform-based trackers, our cross-attention layer combines information from two images to generate merged representations, which selectively highlights the hotspots within the context. Such simple correlation modeling can learn meaningful representations in the capability of both localization and discrimination, thus making it appealing to serve as promising prototype for self-supervised representation learning. Driven by this revelation, we present the novel crop and pretext task for self-supervised video training, doubled as correlational image modeling. Training a standard correlational tracking model, however, requires access to numerous labeled data, which is unavailable in unsupervised learning. Also, the task of video tracking is interestingly evolving towards one-shot object detection, demanding rich prior knowledge of objects were necessary for repeated learning. Therefore, it is non-trivial to retrofit supervised correlation modeling for video tracking into a useful self-supervised pretext task. To enable correlational modeling for effective self-supervised visual training, we introduce three key designs. First, to generate useful exemplar-context files, we consider cropping image regions with various scale, shape, rotations, and transformations. Second, we employ a bootstrap learning framework that involves learning online and targeting encoders. During pre-training, the former takes the exemplar as the input, while later converts the context. Third, we model the output correlation map, or a simple cross-retention block, within which the context serves the queries and the exemplar offers keys and values. This is a procedure to generate the exemplar context file. Note that the corresponding correlation map can be derived from the exact crop region directly. No human labeling cost is needed. We demonstrate the advantages of method in learning effective representations for both VIT and resident models that can perform on par or better than current state self-supervised learners. Our pre-trained representations can also be transferred on the semantic interpretation benchmark. We show the robustness of our model that covers the challenge of adversarial attack, common corruption, and auto-distribution. We can observe that predicted correlation maps can match closely with the corresponding ground truth correlations under various scale, shape, rotations, and transformations. We hope our work can motivate future research in exploring new, useful pretext tasks for self-supervised video training.